Welcome to the CompTIA A+ 220-1101 Core 1 exam. Objective 2.1 Common Network Ports. In our previous video, we talked about how services have port numbers that they use so that other devices can communicate and use those services. We refer to these as well-known port numbers because both the server and the client need to know exactly what port number they'll use to communicate. This is not only important for the server and the client, but it's also important for any firewalls that may be in the middle of the communication. Firewalls have to decide whether they allow or disallow this traffic, and then they often make that decision based on the port number. As we go through this video, you'll see that there are a lot of different port numbers that you should use. And if you've never worked with port numbers before, this will seem like rote memorization. But the port numbers themselves become easier and easier to remember as you can continue to use them. It's important to know that these port numbers and what protocols are often used by a particular port number. But it's also important to know when you would use these protocols. For example, your exam might ask you what port number is used by an application that transfers data in a particular way across the network. Let's start our conversation of port number with FTP, or the File Transfer Protocol. As the name implies, this is a protocol that transfers files from one device to another. There are two port numbers used by this. One is TCP over 20. This is for data transfers, and the other is TCP over 21, which is used to control the data transfers. FTP is a generic way to transfer data between devices, but it's commonly required for some type of authentication to log in for that remote device. So you might use a username and password, although some systems will allow you to log in as anonymous and use any password to gain access. The FTP protocol also includes a number of file management functions. So when you can connect to an FTP server, you can list all the files on that server. You can add, delete, rename, and perform other file management functions, all by using FTP. There may be times when you need to connect to a remote device through a terminal or a command line front end. It's common to use Secure Shell or SSH to provide this terminal connection to a remote device. SSH commonly communicates TCP over 22, and it has text-based front end to be able to access the remote device. Although we see plain text on our screen, any communication sent over the network is secure and encrypted. This is why the name Secure comes from the name Secure Shell. There's another way to connect to a remote device using this text-based or console front end, and it's using Telnet, or the Telecommunications Network Protocol. Telnet commonly uses TCP port 23 to provide this connection. Just like SSH, Telnet provides this text-based front end that allows us to connect to the remote console of another device. But unlike SSH, all of the communication between this Telnet front end and the Telnet server is all in the clear, or not encrypted. That means that anyone who might be capturing the packets between these two devices will see anything that you're seeing over the network, like usernames, passwords, or anything else that might be sensitive. This is why we often say you shouldn't use Telnet on production networks. Instead, you should always use Secure Shell. There are probably millions of email servers that are located on the internet, and the protocol that those email servers use to communicate with each other is Simple Mail Transfer Protocol, or SMTP. SMTP commonly uses TCP using port 25. Not only is SMTP used to communicate between mail servers, but is also used for mail clients to send mail to a mail server. So if you're using a mail client on your mobile device or your desktop computer and you're sending an email message, you could be using SMTP. Although it's common to use SMTP to send mail, Receiving mail is done using a completely different set of protocols. So if you were to look at your mail client, you're probably using IMAP and POP3 to be able to receive mail, and SMTP to send mail. If you need to connect to a remote website, you probably need to type something into your browser, like google.com. Behind the scenes, you need a system that's able to communicate and know what google.com means. But computers have no idea. They just understand IP addresses. So able to solve an IP address from that qualified domain name, you need to use what's called DNS, or a domain name system. DNS commonly uses UDP port over 53 to be able to make this connection between you and the DNS server. These are obviously very critical resources because we couldn't use the internet or browse to a site without knowing the address name. If you've ever used your mobile device on a Wi-Fi network in a coffee shop, then you've received an IP address automatically. This IP address was assigned to you using the Dynamic Host Configuration Protocol, or DHCP. DHCP functions on UDP over 67 and UDP over 68. Of course, you need a DHCP server to assign these IP addresses, but today we commonly get it automatically from Wi-Fi and different routers that we use. The DHCP server will have a large pool of IP addresses that can be assigned to devices on your network. All of these IP addresses are assigned in real time. So when you start up your computer, it queries with the DHCP server, and the DHCP server assigns an address to your device. DHCP uses a leasing system to assign these IP addresses, so you are only using this IP address for a certain amount of time. And after that lease expires and you're no longer on the network, the IP address goes back to the pool for someone else to use. Network administrators can also configure DHCP servers to always assign the same IP address to certain devices. So if there are routers, firewalls, and switches and other infrastructure devices on your network, the network administrator may reserve addresses for them. If you ever used a web browser, then you've used HTTP and HTTPS. HTTP is the Hypertext Transfer Protocol, and this is the common protocol used by our web browsers to communicate to web servers. There are two different ways to communicate. One, you're communicating in the clear, or it's not encrypted, which is the regular HTTP protocol, which uses TCP over port 80. Or there is an encrypted connection that you can use with HTTPS, the S standing for secure, and that uses TCP port 443. We mentioned earlier that sending email messages can use SMTP, or the Simple Mail Transfer Protocol, but to receive email messages you would need to use POP3 or IMAP. POP3 is the Post Office Protocol version 3, and it commonly uses TCP port over 110. POP3 was designed to retrieve email messages to an email client, but wasn't built for multiple email clients. And of course, these days we tend to walk around with many different mobile devices and different mailboxes that need to be synchronized across many devices at the same time. We commonly use IMAP, or the Internet Message Access Protocol version 4 over TCP 143 to be able to download and manage mailboxes. Many operating systems have their own method of transferring files and information between devices. Using that operating system, Windows commonly uses the Server Message Block, or SMB, to be able to provide this connection. This is the protocol commonly used by Microsoft Windows. So if you're transferring files between devices, or you're sending a print job to a printer, it's probably using SMB. You might hear SMB referred to as CIFS, or the Common Internet File System. SMB uses a number of different protocols to be able to communicate. And if you're on an older Windows machine, you may be using NetBIOS over TCP/IP. NetBIOS is the Network Basic Input-Output System. This uses UDP over port 137 as a name service function. And you can get the name and different information of the session from TCP over 139 to set up the session between the devices. If you plan on doing any work as a net admin, then you'll become familiar with SNMP, or the Simple Network Management Protocol. SNMP allows a network management device to query these infrastructure devices for performance details and receive those metrics in return. This uses UDP port 161 to perform these queries. You can configure the infrastructure device to monitor for certain metrics, and if it exceeds those metrics, then it can send alerts. It uses UDP over port 162. There's different versions. Version 1 was in the clear and the structure of data wasn't as complex. Version 2, there's a lot of data enhancements and different tables they use, but it's still in the clear. Version 3 was much more secure standard with authentication and data integrity with encryption. We use directories extensively on our modern networks, and one very common protocol to use to query these directories is LDAP. LDAP is the Lightweight Directory Access Protocol, and it commonly uses port TCP over 389. There are many implementations of LDAP, but one that is most popular is Microsoft Active Directory, which allows you to query that Active Directory service using LDAP. If you've ever worked in a support role or in a help desk, then you probably perform some type of remote access to someone's desktop. One very popular protocol to provide this remote communication is RDP, or the Remote Desktop Protocol. This is the standard protocol used by Windows for remote sharing and is commonly used TCP over 3389. There's so many different versions of it today. You can connect from all kinds of different clients to a host, and you can control either the whole computer or just an application. And we are at the end of the common network ports. Here's a pop quiz. Okay, what TCP port number does FTP use? So A19, B20, C22, or D23? And the answer is TCP over port 20. So 20 is sending the data and 21 is controlling the sessions. Thank you.